Hello everyone, good evening. I'm Abhishek, and today we are going to look into some CSS units we generally use, right? Here's the index of the subject. First, we shall have some intro and types of the CSS units. After that, how do we implement it in the typography, right? And in the last chapter, we shall look into some newer CSS viewport units, right? So let's start with the introduction of the CSS units. In general, we are nowadays we are using the pixels, points, rem, percentage, and few other viewport related viewport related CSS units. When I say viewport related CSS units, we shall consider the VW, VH, Vmin, and Vmax, right? So based on their characteristics, we can classify these CSS units in two parts, two ways, right? First one is the absolute CSS units, and second one is the relative CSS units, right? We can consider pixel points as an absolute values, right? Because they are not relative or dependent on anything. Whereas when we consider the REM, M, or viewport CSS units, those are considered as relative units because those values are not fixed and they are relative to something else like the browser's default font size or the parent element or the you can say the root element, right? So those are the characteristics of the relative values, the relative units, right? In this slide, we shall be mainly focusing on two CSS units because we frequently use these two units with our font sizes, right? First one is the M. M value, the value of M depends on its nearest element, right? And it also has some inheritance issue. That's why it's very hard to difficult the M value, right? To fix the problems with the M value, uh, developers invented the REM, right? So REM values are related to the root font size, or we can say the font size of the HTML element. And when it's not explicitly set, then the REM will take its value from the browser's default font size, which is generally is set to 16 pixel by default. So those are the you can say a little about the M and REM values. Now I'm I'm taking you to the implementation. How do we use M and REM and how does it affect our implementation in responsive layouts, right? So as I have told earlier that REM values are relative to the root font size. This means if you set a font size to the if you set a font size 16 pixel to the HTML element, right, then the value of the one REM will be equal to the 16 pixel, right? And from where M takes its value, M takes its value depending on its nearest parent, right? But as I told you that we shall be using REM frequently, not M, but why still M is in the play? Because it helps us uh, to scale your web page on modular level. Now I'm taking you guys to some demo. What does it mean by modular level and what does the REM do? Okay, so this is a very simple implementation, right? And if you guys can see, I'm setting the font size of this paragraph to 1 REM, right? And let me take you to the file as well. This is the root element we say. This is the topmost element of any document, HTML document, right? The HTML. Here I'm setting the font size 20 pixel, right? So on the desktop sizes, we can see our font size is looking like it's 20 pixels, right? Now, what I'm doing here next, below the screen width of 1200, I'm reducing the font size of HTML element and setting it to the 16 pixel. So when I scale down my browser window and taking it to the below 1200, you can see a clear difference in the font size in between the desktop and the tab devices, right? So right now, what is the value of REM? It's 1M. Oh, sorry, it's 16 pixel. Now, if I scale down more to the mobile sizes, here I'm setting the font size 12 pixel. You may not experience much difference in between the tab and the mobile devices. So to show you the difference, let me reduce it, scale it down more. Now the difference is very clear, right? So this is the font size we see on the mobile devices, right? This is the font size we see uh, above the screen width of 768, right? And the final font size we have set for the desktops, that is the 20 pixel. So this is the way REM takes its value from the root element, and we consider that if we use pixels everywhere, right, then it won't be possible to scale down the font sizes on the lower screen sizes, right? That's the first thing. Now I'm coming to the M method, right? As I uh, told you, as I said that we can control how the web page scales on modular level. So in my current implementation, everywhere the REM will take value from its root element, means the HTML element. But you guys can see the different font size on the navigation items. So how does it? How does the anchor tag? Here I'm setting the 1M font size for the anchor tag. And what is the font? What is the value of 1M here? The nearest parent where we are setting the font size is the sidebar element. Where I'm sorry, I'm sorry. Here, the parent is the UL element, right? Unordered list. So here I'm setting the font size 30 pixel. Now, when setting the font size on the child element to the 1em, right now the value of 1em is equal to the 30 pixel. So that's the place from where m is taking its value, its nearest parent. So here we can say that we can use m unit when we need to design or we need to display something other than the global styling implementation or the other than the global font size implementation. So we can use the empirical method. Otherwise, we are good to go with the REM method. So now I'm moving to the next slide. Okay, so since March 2022, there have been few newer viewport units, right? Like SVH, LVH, and SVW, LVW, and DBW, right? So what is the difference and what was the need to create new CSS units while viewport height, VH and VW were already in the market? So please pay attention on this image. See, Okay, so here this image is showing straight dimensions about the SVH and LVH and DVH. First, I want to address one issue which was aligned with the VH property, the viewport height. So before March 2022, there was only one unit, that was the viewport height. And what uh, dimension or what height it calculates, it simply includes the address bar of the browsers, especially in the mobile browsers, right? So whenever, if you set an element to 100 viewport height, it will not provide you the exact dimension where your web page lies. It will add the height of the address bar as well, right? So that was the need to create or invent new viewport units, right? So basically units are old, but you can consider S, L, and D as a modifier. Consider the SVH. If I remove the S, it is the same old viewport unit, right? But we are adding the modifiers. S stands for smallest, L stands for largest, and D stands for dynamic. And those modifiers can be added in every viewport related units. Those were already available, like the viewport width, vmin, and vmax. These are the old viewport units where you can add the modifiers and convert them into a new CSS units, right? So let's look how did they resolve that address bar issue with newer CSS units. Consider the first uh, diagram, right? The 100 SVH. Here it's saying the SVH, smallest viewport height. So when you set something to SVH, it will simply exclude the height of the address bar. Coming to the second diagram, this is set to the 100 largest viewport height, LVH, right? When you set height of an element to 100 LVH, it will simply include the address height of the address bar. So this is how work the largest and the smallest. Now coming to the DVH. D stand for, as I said, D stand for dynamic viewport height, right? So those guys having iPhones, right? You guys can notice the behavior of Safari browser in mobiles. When you scroll down, the address bar and the interfaces of the user agent will shrink a bit, right? On few mobile devices, it simply goes away, right, to provide more space to the content, correct? But on fewer iOS devices, the address bar and the user agent interfaces will just shrink a bit, right? So what DVH will does, it will set the value of the element on the initial page load, just like the 100 SVH does. As soon as you start scrolling down the page, it will start behaving like a 100 LVH. Means when you start scrolling down the page, right, your address bar would shrink, right, resulting in an increased height of the viewport. So what DVH will do at that time, once your viewport height is increased, DVH will DVH will set that height, increased height, to your element. So that's the main difference from the old viewport height unit to the newer viewport height units. Newer viewport height unit provides you three methods, whereas the old viewport height came with only one feature. The same effect, the same modifiers S, V, and D can be added. Same as the VH unit, we can add modifiers in viewport width, turning them into more precise viewport units like SVW, smallest viewport width, largest viewport width, and dynamic viewport width. But in the case of viewport width, we shall consider the scroll bar. As in the case of height, we have been considering the address bar. In the case of viewport width, we shall consider the scroll bar, because in the windows we see the scroll bar in the Chrome browser, or when you open the Chrome in the Mac operating system, there will be no scroll bar. Same situation comes with the Safari browser, right? So here we can use the SVW to take the width of the scroll bar or ignore it, right? So this is the this was all about the viewport width with the modifiers. Now, same case comes with the old vmin and vmax CSS units. Here you can add the modifiers and turn them into a newer CSS units, right? Now, coming to the VI and VB, these are completely new CSS units introduced in March 2022, right? So basically, VI refers to the viewport size in the inline direction. For English text, the inline direction refers to the width of writing from left to right. And as we know, Chinese is written from top to bottom, right? So here, one thing I just wanted to mention here, I tried to search the practical implementation of the VI and VB, but unfortunately, I could not find any suitable tutorial for that. So I just wrote the definition here, right? Technically, I should create a practical for that, right? But as I didn't find any proper tutorial for that, so I just noted down their definitions and just trying to tell you guys that these are the very new CSS properties, right? And I'll try to cover it in my next TECHX session, right? But for now, uh, we can be familiar with their names, like the VI stands for the viewport inline, and VB stands for the viewport block. VI basically VI unit basically covers the horizontal section of your web page, right? Means if you set the value 10 VI, that means it will take the 10% horizontal space of your viewport screen. And same comes the VB, but in the viewport block unit, right? This unit tends to cover the vertical area of your web page, right? So I'm sorry about that. This VI and VB. I'll try to cover uh, these two units in more detail in my next TechX. But for now, that's all from my side about the VB and VI. So now, guys, if you have any questions, please ask.
Hi guys, thank you for watching. I had an amazing time learning all the new things here at Specbee's TechX. And if you did too, do let us know in the comments below. Keep following Specbee for the latest trends in technology. See you in the next one.